All right, welcome back, Geometry. Last little bit of, what are we in, 9.5, the symmetry section. We're going to get into three-dimensional figures. So a three-dimensional figure has plane symmetry. It's similar to line symmetry for a two-dimensional figure. If a plane can divide the figure into two congruent halves, and actually if you reflected that in like this three-dimensional object through that plane, it would reflect onto itself similar to before. So that's plane symmetry, something to look out for. And then the other type we can have is we can have rotational symmetry, but we're not rotating around a point, we're rotating around an axis. So if we like spin this this cylinder here around that axis, it has rotational symmetry. And actually this is a kind of a weird example where you can actually rotate that. Like if you were talking about the order, the number of the different ways it would line up with itself. With a cylinder, a perfect circle, it's just like you can twist it in infinitely small parts. So like there's actually an infinite number of rotations between 0 and 360 that would line up with itself. But it has rotational symmetry. It will line up with itself after a rotation. All right, so we're going to basically just kind of think through each of these figures. Sorry, this didn't copy out super well. It has plane symmetry, axis symmetry, both or neither. All right, so this one, this is supposed to be like a square pyramid here, and it's supposed to be regular, so you know it's not, if it looks a little wonky. We are supposed to have a couple of things. We could slice this with a couple of different planes, and I'm going to try and draw this. This is hard to do for me, but so if I cut it down here, let's see, with a plane. Actually, we don't need to do that. So we have a plane cutting it like there. Oh, that was terrible. So I don't know, we could cut straight back through it. We could also cut this way through the kind of the middle of it, like cutting down that side and this side. So I don't know. I didn't draw it super well, but yeah, there's a couple of planes. You could cut it through the middle, you know, slicing this way. You could also slice it that way. To get plane symmetry. And then we also have, so we didn't have to know all these, but we could also slice it this way. So it's like, I don't know, we could slice it, these are bad drawings, slice it that way from corner to corner across the square through the peak, and we could also slice it finally, and this is just getting to be a non whatever, we could slice it that way. So yeah, we've got actually a bunch of planes. We've got and it's kind of the same as the square that is on its base. We've got four, so we got 1, 2, and then 3, 4 different ways that we could slice that thing. All right, and then we could also rotate it. We could rotate it around its center. All right, and so if we had like the rotation of that, maybe I've made this such a mess you can't see that, but yeah, if we rotate that prism around its center, it would line up with itself. It would line up with itself 4 times actually. All right, this one we have actually it's like it was a square prism, but it had sorry, not prism, pyramid, but it had like a bite taken out of it, like a chunk, a quarter of it taken out. So that's going to limit us down. So we end up being able to slice it if we had like a plane. And I don't know if we slice it back like right through the middle, kind of going right along that line. If we slice it in half there, then we get plane symmetry, but we don't have, so this one had both, by the way. This one just has plane symmetry. It does not have rotational symmetry. There's no way we could rotate that and get back to the same spot. This one here, we could slice this L, like there's nothing we can do going kind of like this way, chop in or anything like that, but we could slice it in half this way, kind of, if I had like a plane going through it this way and it was like cutting, you know, cutting at those spots. So we could slice it in half in that way and it would have plane symmetry. And this one has no rotational symmetry, so just plane. This next one, this is like a triangular prism, a right triangle, and this prism going back. So this one we could slice kind of that sideways direction, so it like slices through there, up there, and slice it in half. You know, kind of, I guess, this way, slicing through it, but no rotational symmetry for that one, so just plane symmetry. This next one is a cone, it's supposed to be a circular cone, so yeah, this one, it's one of those where we could actually have infinitely many planes cutting it into two congruent halves, like at any angle along that vertical axis, right? So if this is your vertical axis going through it, then yeah, we could do any plane that goes through that line would cut that into two halves. We can also rotate it any number of degrees. So this has both, and it has like infinitely many of both, like infinite order and infinitely many planes. And this last one is just kind of wonky. Basically, it's the cone, but we nicked it a little bit. It's hard to tell from the picture, but the way that this has been drawn, we're gonna say no. If it was just like a symmetric lip, but it curves up and points down, we're gonna go with it. It doesn't have either because of that. But if it was just like a nice little bump up on one side, we might be able to actually get plane symmetry if we slice through it. We're gonna call this a non-symmetrical, like, I don't know, oddity there. So we're gonna go neither on that one. All right, and that's some three-dimensional symmetry.